All right, let's talk about acceleration. A couple of setups to start. So, this is you at the top of a cliff. You throw a ball up at a certain velocity, and then it circles around and comes down and hits the ground down here. Now you take a second ball and you throw it at the same velocity that you threw this one up. You throw it down. Which one hits the ground traveling faster? Answer: neither. Whoops. Same velocity. Okay, so what's going to happen here is that when you throw this one down, it's got a velocity and it's going to start to get faster and faster and faster because gravity will speed it up and it's going to hit the ground here. When you throw this ball up at the same velocity, gravity will start to slow it down, slower, slower, slower. At the top, its velocity will be 0, and then it will start to pick up speed. And when it gets to the exact same height that it took off from, it will have the same v as it left, the hand here. So really, we've got, in both situations, you've got a ball leaving this height with the same starting velocity, so they should have the same velocity at the bottom. Next up, we have two paths. We have a ball here. It's going to go down a little ramp, roll along, and then up a ramp to here. And we've got another ball right here. It's going to go down a ramp, down another ramp, up, and return to the same height. Which gets there faster? A or B? It is B. Why? Because B has got this little part right here where there's extra acceleration. So we'll say because of extra acceleration. Yes, it's going to this point will be exactly the same for both. But then this guy's going to drop some more. It's going to travel this portion faster than a similar portion up here. It's going to slow down. Now they'll both be the same speed right here and here, and then they'll slow down again here. So acceleration is the rate of change of velocity. It's how fast velocity changes. Now, some examples for this are plane taking off. I need that plane from basically rest to get moving before it hits the end of the runway, so we go up. Hitting the gas. Gas pedal in your car or your parents. Another one would be driving around a circular path with speed constant. And that's a tricky one. But it's because of this next line here. Acceleration is a vector, not a scalar. So when I look at this one right here, if this is my road, yes, and I'm going to do it, I'm coming in my car right here, I'm driving down the road, and I make a turn and my speed doesn't change, my direction has. So even though the speed is constant, because my direction is changed and acceleration is a vector, this thing has accelerated because the velocity has changed, because part of it, the direction has changed. A little formula here: acceleration is delta v, or the change in v over the change in time. And just like in math, it's always the change in anything is going to be final minus initial. Sometimes you might see it written as v2 minus v1, or sometimes, oh no, yeah, those will be the two big ones, the two major ways to see it written, both on the internet and in textbooks. So let's do a little example here. car accelerates from 16 meters per second north to 24 meters per second north, and it takes 4 seconds to do this. What's its acceleration? So the question is asking for what is its acceleration. The initial velocity is 16. Now remember what you need to do in all of these questions to get full marks. You have to write out your given properly. The time it takes is 4 seconds. So I'm going to write out my formula, Vf minus Vi, make those vectors, over t. I plug in, I'm going to get 24 minus 16 over 4, which is 2 meters per second squared. And the direction is north. Please note here the units in the metric system, which is SI system, meters per second squared. And remember, this question will be worth 3 marks. 1 mark for your given, must have the proper units, 1 mark for your formula, and 1 mark for your answer. This question is out of 3 marks. And if you want 3 marks, you will do those 3 things, or you will not receive 3 marks.